Right, okay folks, so today we're going to start a new topic of differential equations. Okay. And the first part we're going to look at, there's three different types, but we're going to look at first order differential equations, but the separable kind. Okay, so that's actually going to be the first type we're going to look at. We're going to spend our time looking at that today. So the other type is going to be called first order linear, and then we're going to look at second order, but that's the first one we look at, is first order differential separable. So any first order differential equation that can be expressed of the form, okay, so any first order differential equation that can be expressed in the form. Okay, so if we have a function of y that's multiplying dy by dx, and that equals a function g, which is just purely of x, then it can be solved by separating variables. Okay, so the variables I mean by x and y, and hence why it gets the name, I'll write it in brackets here, variable separable. Okay, so that's how this is going to work. Okay, we're going to be given functions or a differential equation that we have to solve that is a function of y multiplied by dy by dx equals some function g of x there. And how we separate it is we will get the y's on one side and the x's on the other side. Okay. Now, what I didn't say is what I mentioned at the start. What we're doing here is we're given a function that's got dy by dx in it already. And our job is to work out what the function y was. Yeah, what function of y would satisfy this type of equation, okay, in order for this to be true. So that's what the task is here. So let's go through what we've got here. So let's go back to the function that I've got. So suppose I've got f of y dy by dx equals some function g of x. Okay. Then what we want to do is, let's say we integrate both sides. Okay, so if I put an integral over that side, but let's suppose I'm integrating this side with respect to x, so I'm going to have to put a dx there as well. Okay, and then I integrate the other side by x well, so that's with respect to x dx. Then what can happen here is that the dx is cancelled there, so I actually just end up with the function of y integrated with respect to y, I've got dy left, and nothing happens on this side. So I'm integrating the right hand side with respect to x there, okay? So that is how we're actually going to solve this. What we're going to do is we're going to split them both up, so we get y's on the left, y's on the right. Then we're going to integrate the left hand side with respect to y, and integrate the right hand side with respect to x, okay? And that way I'm going to end up with getting my y back, that's what I'm solving for. Okay, so that's just a general form, and that's why it works, because you can integrate both sides with that there, okay? So let's go straight to the example now. Okay, so example 1. Let's find the general solution of And let's give us the equation y dy by dx equals 1 over x squared. Okay, so our question is to find out what was the function of y such that if I differentiated it and I substituted into here, I would end up with that right hand side there. Okay, that's what my aim is to try and find just now. Okay, so if I split them up so I get all the x's on the right hand side, okay, so if I move this dx over here, so that becomes y dy equals 1 over x squared dx. Okay, so remember we need to integrate this, so we're going to integrate left hand side with respect to y and integrate the right hand side with respect to x. Okay, now when we integrate and there's no limits, we're going to get a constant plus c. We'll just have that plus c on the right hand side, okay, because we only need one constant for this equation. Okay, we'll just give it on the right, so we'll just forget the constant on this side just now. So if I do that, what c do I get? So if I integrate y, I'm going to get a half y squared on that side there. If I integrate 1 over x squared, okay, so that's really x to the power negative 2. Okay, so if I add 1 to the power, I get negative 1, divide that by that power. So I'm going to get negative 1 over x plus my constant c. Okay, so that's how I integrate that there. Okay, both of them you get from higher. Now, we wanted to work out what the equation was that gives me y. So if I double everything on that side there, so y squared would equal negative 2 over x. If I double a constant, I still just get that constant, don't I? Okay, so I just don't know what it is, so we'll still call it plus c. Therefore, y would be the square root negative 2 over x plus whatever that constant was. Okay, that's what that function would have had to have been that would have satisfied that equation we started with up the top. Okay, anybody got any questions about that so far? So it's only been one example, but do we understand a bit about getting everything on y on the left side and everything on the right with the x side and then integrating both parts one at a time? Okay, right with that? Okay, we'll look at a couple more examples just to refresh ourselves. Now, one thing I forgot to say actually here. Yes, Carl?
Quick question. Can you go back up a little bit?
Certainly.
It's to do with the standard integral in the formula. Why does that not become log x squared?
Because if you remember what log is, so if I integrate 1 over x, that becomes log x, doesn't it?
Yeah.
Right. The reason being is because if I tried to integrate 1 over x last year,
is it literally because you can actually integrate it if you just do it the same way, but it's impossible to do it like that?
yeah, it's because
the only reason why it's like
it's because I can't do it with that there. Because if I add 1 to the power and divide by the new
so
power,
if it's possibly do it like that, they'll just do it.
yeah, totally. That's from higher. If I gave you that last year, you did that from higher, so that doesn't change. Okay?
Okay.
It's because we couldn't do it for last
So
year.
it's only if it's 1 over x.
It's only if it's a power 1 basically on the bottom. Okay, therefore you need to use your logs to get that. Alright. One thing I forgot to say though is the question said find the general solution. The reason why that's not a general solution is because we don't know what the C is. Yeah, so we don't know what the full answer is, we just know in general it's of that form. What we'll actually see is, maybe not straight away today, is that we'll look at ones that you actually put in information to get what the constant was back out, and then you can actually find the what's called particular solution, the actual full solution, okay? But we'll still stick to the general solution just now. So let's go to example 2. Let's find the general solution. And we'll give the equation x squared dy by dx equals y plus 3. Okay, so that's what we're going to try and find, a y function that would satisfy that equation there. So hopefully you see straight away is that it's sort of the wrong way round, isn't it, this question? Yeah, ideally I want all my y's to be on the left hand side and all my x's to be on the right hand side. So what I'm going to do is I want to sort of group this together. Okay, let's pretend the plus 3 is attached to the y so that when I move the y that's going to move also, okay? So what that becomes is, if I bring this y plus 3 over, yeah, it's going to have to divide, isn't it? So therefore, it's going to be 1 over y plus 3 dy. If I bring the x squared over, that's going to be 1 over x squared, and if I bring the dx round, that goes up and multiplies. So I've got 1 over x squared dx there. Okay. That's been now got my y's on the left hand side, my x is on the right hand side, so I can now put my integration signs on. 1 over 1 plus y plus 3 dy equals the integral 1 over x squared dx. Okay, so that's what I'm going to do. Okay, so now let's think about how we integrate both of these. So, how do I integrate 1 over y plus 3? What will that become after that? That's a log, yeah. The y is just a power 1, so that's just going to be log of y plus 3. That's going to equal, now we know the answer to this, but we've done that in the previous one, okay? We're going to get negative 1 over x plus c. Alright. Okay, so what we want is we still want to get y, don't we? That's the thing that we want to try and get out of this. I've got a log of something to do with y here in this bracket. I need to sort of get rid of that log, don't I? What's the opposite of a log? How do you undo a log? It's an exponential. Exponential logs are the exact opposite. So if you want to get rid of a log, you take an exponential of it. If you want to get rid of an exponential, you take the log of it. They would cancel, okay? So we'll do this in brackets. We'll take exponentials of both sides. Okay, so if I do that, and to show you this actually does cancel, we'll actually take it properly for the first bit. So I'd get exponential of log of the y plus 3. That would equal the exponential of 1 over x squared plus c. So remember, that all that would go to a power. Okay. Now, that and that would cancel, therefore I'm going to get y plus 3 down here. What I'm going to do is I'm going to show you what happens with exponentials. So if you remember your powers of indices, yeah, when you work out something like x squared multiplied by x to the power 4, for example, you would add your powers, wouldn't you? So that means that if it's because I've got an add here, I can split these up into two exponentials. I can have e to the negative 1 over x squared multiplying.
It's only 1 over x. So.
Oh, it's 1 over x, you're right. My apologies. Change that. Good spot. That makes it look a lot better. So 1 over x there. And I've got e to the power c there, okay, multiplying that. So that there, you can write as that, therefore you can write it the reverse way, okay? Now I want you to have a think about e to the power c. C is a constant, isn't it? It's a number. Don't know what the number is, but it's just a number, right? Therefore, what's the exponential of just a number? It's just another number, isn't it? Yeah, it's no functions of x or anything like that. Therefore, I'm actually going to label that a new constant. I'm going to call that a constant a. Okay, it's still a constant, but it's a different form. It's an exponential of it now. Okay, so it has changed a bit. So therefore, y plus 3 equals, well, if that became a constant a, that would be a e to the power negative 1 over x. Okay. So I've just brought that a constant down at the front, so it's multiplying it, just a number. Therefore, if I solve for y, I get a to the power ae to the power 1 over x negative minus 3 if I bring that minus 3 on, okay? That's still a general solution because we don't know what the constant a was, it's just looked like a different form. Okay? That's a more mathematical way of having your constant as a power. Okay, if you can split your whatever it is, exponential as it was in this case, then you can bring it round to the front just as a new constant.
Is that how you just get exponential? You put the e and change it to a power.
What's that come?
Is that all you have to do? Change to an exponential? I can't see the word. Sorry.
Exponential, as in how to get rid of a log sort of thing, or?
Is that how you just add e then make the power like what it was? Right?
Yes. Yeah. If you want to take an exponential something, it just all becomes that power.
Yeah.
An exponential. All right. Any questions on example 2? So example 2 showed us how to deal with a constant regarding an exponential part there. You'll see that a lot. That is quite frequent when we do that technique. and it's much easier because remember what I said about how these are general solutions. If I wanted to work out if I had some more data that could give me the answer to what the constant was to start with, or what the new constant would look like, it's much easier to work out in this form as opposed to involved in a power. Okay, it's much easier to do it that way. Okay, you all right with that, folks? Yep. Okay, right. We'll look at one last example before we'll wrap this up. Okay, so what's the one that I want to do with you today? Let's go for example 3 in this one here. So again, find the general solution of dy by dx equals 1 plus y squared over 1 plus x squared. Okay, so we're going to solve for this here. Okay, right, so let's try and get all the y's to one side, all the x's to the left side. So again, if I think about it as a group, then I'll group that together, I'll group that together so that I'm keeping that with the y squared and that with the x squared. If I bring this over, it's on the top of the fraction this side, so when it comes over, it's going to be on the denominator, it's going to divide, so therefore I'm going to get 1 over 1 plus y squared dy equals, I'm left with 1 plus x squared on the bottom there, dx. Okay. Therefore, if I put my integration signs on, I'm going to have integral of 1 over 1 plus y squared dy equals the integral of 1 over 1 plus x squared dx. Okay. Okay, so if I integrate, what will this become? Go for Gum.
Is it log 1 plus y squared multiplied by 2y or multiplied by 7?
Not quite. I'm somebody to think that. Have a look at your formula sheets again because this is actually a standard integral.
The 1 over 8 tan, inverse tan.
It's the inverse tan, isn't it? Yeah. And it's actually the standard inverse tan one, yeah? As in, like, the a value is just 1. So therefore, I'm going to get tan of the inverse of y equals, and it's going to be the same on the right hand side, just with x, isn't it? It's the exact same function, just with the x variable, so it's tan inverse of x plus a constant c. Alright. And again, let's find how we get just y out of that. So, how do you undo a tan inverse? You would have to take the tan of it. Okay, so therefore the tan and tan inverse would cancel. Tan and tan inverse of that would cancel, so I'm just left with x plus the tan of the constant c. Okay, which again would still be a constant, it's a number, but we just don't know what that would be. So that would be the function of the general form like that. And again, if we had more data, we could work out what that constant would be to find out what it would actually properly mean. But that's that there. So that's solving differential equations type 1, okay? Where it's just trying to find the general solution, okay? Next, what we'll do is we'll look at ones that have more information that gets us the particular solution. But I'll get you to practice some of that just now. Is that okay, folks? Perfect.